In this video, I'll discuss some basic C programming concepts, things that you might be a little bit aware of, but if you've only done something like Python or MATLAB coding, you've never had to really think about. So first, let's discuss how are numbers stored inside of your computer. They're stored digitally with binary encoding, so that means the bits are ones and zeros. So if we have the number 0000, that's a 4-bit number where every bit is a 0. In decimal, we would consider that the number 0. And if we had 0001, that's the number 1. And if we added a 1 in binary to this, we would get 0010, that's the number 2. And so on. I could have a 1, 1 for a 3. If I add 1 to 3, we get 1, 0, 0, that's 4. And you can imagine we go all the way down to having 1, 1, 1, 1, that's the number 15. So we have 4 positions, and they can each have 2 states. So that's 2 to the 4. That's 16 possible different numbers. But we started at 0, so we go from 0 to 15. That's an unsigned version of a number. Now we can also refer to this, instead of being the decimal equivalent, the hexadecimal equivalent. And as we start doing the microcontroller, you'll see reasons why sometimes it's easier to refer to the number as its hexadecimal equivalent or its decimal equivalent, and sometimes even it's easiest to just do it in straight up binary. So hex, we usually start with the prefix 0x to remind ourselves that the number we're about to interpret isn't in base 10 but in base 16. Base 8. So 0 is the same. 1 is the same. It works all the way until we get to 9. So when we have the number 9, we have 0x9. What happens when you add 1 to 9? You get 10. On hexadecimal, you get A. And then A goes down to F. Hexadecimal is sometimes nice because it's easier to count on your fingers. And as we get to different parts of the class, I'll describe how can you count with 8 fingers instead of 10. Okay, data types. If I need to make a variable and I would like to store either a decimal or hexadecimal or binary number inside of it, I need to specify how many bits are in this variable. I need to worry about that. So different types of data would be, so for instance, a char or a car. And that means we're going to have 1 byte of data, which is represented by 8 bits. We'd also have an integer, so int, an int, and this depends on what kind of system you're talking about or maybe what kind of compiler. I'm going to say that an int is 4 bytes, or 32 bits. That way, when I define a long, I can say that that is twice as big. That's 8 bytes, or 64 bits. Of course, these 3 are all integer type variables, and they could be either signed or unsigned. That'll be important. If it's an unsigned number, you can have only positive numbers. If you could have a signed number, you have positive and negative, but the range is shifted, and we'll talk about that more later. We also have the float type variable, which I will define as a 32-bit number. But again, depending on your system, it might be 64. And then the double precision of a float, 64 bits. And these two, of course, are decimal numbers. Decimal numbers we'll discuss a lot when talking about the microcontroller because they cannot be stored as easily inside of a binary number. The bits have different meanings, so the first few bits mean something and the next few bits mean something else, which means that doing math with floating point numbers could possibly take a lot longer than doing integer-based math, which is pretty easy to do. Okay, the last thing we'll talk about in this video are pointers, and pointers in C are probably one of the more complicated topics that we'll have to talk about regarding C. A pointer is the address of the first byte of a variable. And so you can think of all of the memory inside of your computer or the microcontroller as kind of a stack of cards. And each card can be 8 bits or 1 byte. And it has an address. So for instance, I'm drawing that at the bottom. This one's address is probably address 0. And the next byte ahead of it is address 1. And so on until you max out your memory. When we refer to a char's address might be 0 or 1 or any number. And the data that is in that char will be stored in one of these bytes. If I were to define an int, well, an int takes up 4 bytes. 1, 2, 3, 4. So this amount of memory would be required to store an int. And the address to the int would be the first byte. So where is the location of the first byte? So for instance, I could declare an integer int I, and then I could make a pointer to it. I'll call it int IP. So the variable name doesn't really mean anything, but by ending it with the letter P, I'm reminding myself that it is of type an integer, but it's a pointer. So I'm going to put a star in between here. So int star IP is a pointer, and I could say it stores the address of I. So the ampersand character in front of the variable name I means go find me the address of integer I and store it into this variable IP. So IP would tell me the address of I. If I wanted to know what is the value of the variable that's inside the address IP, so for instance I have int j, I could say int j equals star IP. The star character in front of the name of a pointer says, give me the value that is at that address. So saying int j is equal to I is the same thing as saying int j equals star IP. We'll be doing a bunch of other exercises with pointers as we go along because they can be very useful, particularly when sending data back and forth between functions.